Okay, we're back with the rest of the solutions to the Unit 1 review problems over limits, continuity, and elementary function review. This is actually, from here on, all the stuff that's left in this video is actually pre-calculus review. So we had some matching exercises where we were given some graphs on the left hand, column 1, and we were to match them with the type of function that we have here. So if we look at this looks like this might be a polynomial function of even degree with the positive leading coefficient. So that's e. That's a constant function, horizontal line. So that's a. That looks like a sharp corner like that's indicative of an absolute value function, like the absolute value of a linear function. G. L, that's like a sine or a cosine wave there. It's been maybe modified a little, shifted up or whatever. That is a sine or cosine, that's L. B, you see the asymptote on the left, horizontal asymptote, but none on the right, concave up increasing. That's typical of an exponential growth function, exponential with a base bigger than 1. All right, this one has some vertical asymptotes, but otherwise fairly well behaved. This looks like maybe this might be a rational function of some kind. Okay. This could be a power function here. This is one that's even over odd for the power, and the total power is less than 1, but positive, between 0 and 1. So that's like a power function there. Possibly. This is, let's see, this looks kind of like the exponential function that we saw above, but this time the horizontal asymptote's on the right. This is an exponential decay function. It'll be base less than 1. Looks like we have a vertical asymptote and then no horizontal asymptote. That's typical of a logarithmic function. That's a straight line, so that's linear with a negative slope. That looks like a tangent or cotangent, really like a tangent function. That is a step function, maybe a greatest integer function that could be there. O. A secant or cosecant has a shape kind of like this. And another straight line, so it's a linear function. This one has a positive slope. So the point here is that you should be able to recognize some basic shapes of these different types of functions and just kind of know by looking at the kind of shape what kind of function we're dealing with. You should be comfortable enough with these different types of functions to just know that. I actually did one of these earlier in the same set here. Here's a function. We were just given the black part of this table, these two columns right here, and we notice that the delta t is 2 each time. And if we divide one of these by the previous one, it at least is approximately 1.1. You take the 1/2 power of that, that's 1.05, or at least approximately so. And so this looks like this is a constant base, defined by this. So that makes it an exponential function with a, in this case, a 5% growth rate. So that's 1.05 for the base to the t power. And your initial part would be when t is 0, we would just be going back one more level here. So we'd be dividing that by 1.10, and we get about 2.195. Or in other words, solve this equation here by plugging in an x and y and solve for that. And we could check it with a graphing calculator by putting the formula in, look at the part of the table that we have here, and at least as far as rounding off, it does work out exactly what we've got up here, at least rounded off to that number of places. The next one is linear. We're going up by 2 each time on the input, and the output is going up by 30 each time, so that's a slope of 15. So it's 15 there. We just need to figure out the other point there. We can put in our point, say 2 and 23, solve for the y-intercept of -7, or extend this back by, one more step back by subtracting 30. And we get 15t minus 7. So that's linear, and again, we can check that with a calculator if we want. Now, these are some shapes here. So this is increasing linear, increasing concave up, decreasing concave up, decreasing concave down, increasing concave down, and decreasing linear. The other one we could have added would be horizontal, which would be constant. Which ones are increasing? A, B, and E. Which ones are decreasing? The other ones, C, D, and F. Which are linear? That's A and F. Which are concave up? That's B and C. And concave down is D and E. And which one best fits this? Well, let's see. Delta T is 2 each time, and the delta G or delta Y is changing. Divide by 2, we get the slopes. We see the slopes are all negative, so that tells us that the function is decreasing. So now we're already down to, just because of decreasing, that makes us either C, D, or F. They're not all the same, so it's not the linear one. They're actually decreasing less at first and more later on. That's D, concave down. So D is the best basic shape there. A freezer depreciates at rate of 15% per year and is purchased new for $725. Since it's 15% each year that's going down, this is an exponential decay function. Okay, and the rate of change there is negative 15% in decimal form is negative 0.15, and the units of that are dollars per year. That's not correct. And that's not dollars per year, that's percent per year. Because it's a constant percentage change. Okay, a constant dollar change per year would be linear. Constant percentage change is exponential. So the formula is the amount is the initial amount times 1 plus the rate to the power of the number of years. So this is per year, percent per year. So this is T is in years. 1 plus 0.15 plus negative 0.15 is 0.85. So if you lose 15% each year, you keep 85%. V is the value that's kept. So each year we're multiplying by 85% of the year before. And the initial amount is 725. So there's the formula right there. V of T equals 725 times parentheses 8.5 to the T power. What's its value after 4 years? Just plug in 4 for T and work that out. Use a calculator. It's about $389. Probably I should have rounded off to $390. The 15% is probably 2 significant digit things. So the answer is probably best $390. Probably I should say. Why not? Let's round it off to that. And how long will it take to depreciate to half of its original value? So we put 725 divided by 2 over here. Notice the 725s cancel out. So it really didn't matter how much it was worth at the beginning. Anything that's going to depreciate at 15% per year will reach its half-life or half value in the same amount of time. And so that's 1/2 or 0.5 here is the base to the T power. Do the logarithm of both sides. Natural log of 0.5 is natural log of this side. Now using a property of logarithms, we can pull that T out front. And we get this so that the T is the natural log of the percentage remaining over natural log of the base here. And that works out to be about 4.265 years or about 4 years and 3 months. Next, we have the owner of a small construction business needs a new truck. She's buying a diesel truck for $18,500 and estimates it will cost her 16 cents per mile to operate. The company normally keeps the truck for 5 years and averages 25,000 miles per year. So write a formula that gives the total cost of operating the diesel truck as a function of the number of miles driven. The cost increases as a constant rate per mile. So the function is linear with a slope or rate of change at $0.16 per mile. So the formula then is C of M equals 0.16 times the number of miles, M, plus the fixed cost of $18,500. And that will give the cost in dollars, where the input is in miles. What's the estimated cost over its lifetime? Well, 5 years times 25,000 miles per year is 125,000 miles. The cost of driving 125,000 miles, you can see by plugging in there, is $38,500. That's the cost of owning and operating the truck. Okay, and this next one we're given three different functions. F is given by this table, the function H is given by this formula, and the function G is given by this graph. F of 3, well, F is the table, so when I say F of 3, 3 is the input, I want the corresponding output. Look for 3 in the first column, and then the answer is going to be the second column. So we're looking at that point there, 3, 6, so the answer is just a 6. G of 4, we want to do the same thing, but we want to do it from a graph. We find 4 on the input, come down and find the output is negative 6. F inverse of 3 is we want to go backwards from this, so we find 3 here, and we in the output, and we find out what the inverse of that is, find the input, which is negative 3. So the output of F inverse is the input of F. Now we do composition. G compose F compose H of 2. We read these functions backwards, that is from right to left. So we start with an input of 2. We apply the function H. H of 2 is found by plugging 2 in place of X of the formula here. Let's see, 2 squared is 4 times 2 is 8, minus 6 is 2, plus 3 more is 5. So 2 gets mapped to 5 by the function H. Then the output of the first step becomes the input for the next step. So the output of H becomes the input for F. We want to find F of 5. That's right here. F of 5 is 1, so that goes 5 to 1. And then the output of that step becomes the input for G. We find the input of 1 here, and we go up and find the output is 24. Ultimately, this function, composition of 3 different things, it produces the ordered pair 2, 24, and this is the output here of 24 is the answer. If we say g of x is 0, that's g of x is the graph, we're saying the y is 0, that means it's on the x-axis. The natural question is what are the x's? And the x has got to be an element of this set, either negative 2, 3, or 5. And there it is in set notation. Next, we're given a bunch of lines here, and they're all labeled by certain numbers. And let's see if we understand some things here. Which ones have positive slope? Well, that would be C, E, G, and H. Which ones have negative slope? Well, they go down from left to right. That would be this one, I, F, and B, B-I-F. Which one doesn't even have a slope at all? Slope is undefined. Slope does not exist. That's a vertical line, D. Which ones has a 0 slope? Didn't ask that, but that is A. Notice a 0 is a legitimate number. A does have a slope, it's 0. D doesn't even have a slope at all. Which one has the greatest slope? Well, certainly positives are greater than 0 or negatives. This one doesn't have a slope at all, so it's got to be one of the positive ones. It's either C, E, G, or H, and it'll be the steepest one of those, H. When you go to the right one, H goes up more than any of the others. So that'll be H. Notice I didn't actually have to figure out what the numbers of the slopes were for any of those questions, although I certainly could have. Which ones is parallel to the line 2x minus 3y equals 9? So if we'll solve this for y, let's see, we would add a negative 2x to both sides, and then divide by negative 3. Negative 2 divided by negative 3 is 2/3, and that's the coefficient of the x, so that's the slope. So which one has the slope of 2/3? Okay, so that was when you go the right one, you go up 2/3. Looks like C might be it. Or another way to say this is you go the right 3 and you go up 2. So we can find a nice little lattice point, like right here where it crosses on the corner of a grid. We go the right 3 and up 2, it should cross another corner. Yes, it does. So there we go. Which one has the same y-intercept as this same function? Again, if we solve this for y, what do we get? We get y equals 2/3 x. And then what was the other part? So this is, let's see, it is negative 2x, and then divided by negative 3. I already did that. And then you got 9 divided by negative 3 is negative 3. So that's the same equation, just solved for y. And when we do that, solving for y, we know that's slope y-intercept form. So the same y-intercept, so it's going to have a y-intercept of negative 3, 0, negative 3. So where is the one that goes through there? Looks like that is this one right here. What number is that? That is h. And I believe that comes to the end of our little exercises. So hopefully you have worked through these, then checked your exercises. Hope you did well. And hopefully that you'll find that as a useful little review over this unit.